Let's do another example, problem 10, chapter 3. Here we have this cart and a cylinder which is sitting on the cart, and we are applying force P to it, to both of them together to the cart. And we want to find the reaction forces at A and B. And we are assuming there is no friction between the cylinder and cart, and there is no friction between the cart and ground as well. So to solve this problem, of course, we are going to draw the free body diagram of this to show these two forces and also mg, and write the Newton equation to find these two forces. But if you start doing that, you're going to realize you need the acceleration of the cylinder to solve, to find A and B, the reactions at A and B. And to do that, you can actually simply just look at the whole system together. If you look at the cart and cylinder together, and draw the free body diagram of it, you are going to be able to easily find acceleration of the cart and cylinder together in the x direction and use it in the free body diagram of the cylinder alone. So if I want to draw the free body diagram of the cart and cylinder together, I'm going to have reaction forces here and here, which you can show it because I don't care about the individual reaction forces at this point and this point. You can combine them together and show them at once. So I'm going to have one reaction force from the ground to the cart, which is summation of these two reaction forces. And also we have gravitational force. Mass of the cylinder is m, mass of the cart is capital M. So together we are going to have m plus capital M times g. And we have this external force. For this problem, we are going to use xy coordinate, which is obvious why. And sum of the forces in the x direction here is going to be mass times acceleration in the x direction. But because the acceleration in the x direction is the only acceleration, I'm going to go just with A. The only force we have in the x direction is P. So P is going to be equal to mass of the system, which is m plus capital M, times A. So from here, the acceleration is going to turn out to be P divided by the total mass. Now, I can move on and draw the free body diagram of the cylinder alone. In this one, we have gravitational force, we have reaction force at A, and reaction force at B. And again, I'm going to use xy coordinates. I have two unknowns here, A and B. So I need two equations to find them. A Newton equation is going to be two equations in x and y direction, which is going to be enough to find A and B. Sum of the forces in the x direction is equal to mass times acceleration. The force in the x direction is going to be A times cosine of this angle minus B times cosine of this angle. And this angle is going to be 30 degrees. Same thing here. So the forces that we have in the x direction is going to be A times cosine of 30 minus B times cosine of 30. Or you can write it as A minus B times cosine of 30 is equal to the mass of the system, which is a small m, times acceleration, which is this. For now, let's just write it A. And sum of the forces in the y direction is going to be equal to 0 because there is no movement in the y direction. So component of A in the y direction is A times sine of 30. Same thing for B. B times sine of 30. And we have mg in the negative direction. So A plus B times sine of 30 minus mg is going to be equal to 0. So we got two equations, one here and one here. Let's name them 1, 2, and also this one 3. From 2 and 3, we can find A and B. To do that, you have different options. For example, you can write this as A minus B is equal to MA divided by cosine of 30. And cosine of 30 is root square of 3 divided by 2. And this one you can write it as A plus B is equal to mg divided by sine of 30. and sine of 30 is 1/2. Then if you add the equations together, you're gonna have 2a here. You can eliminate b and find a. After that, you can put it back here to find b. I'm gonna let you do that part yourself. And at the end, if you do it correctly, you're gonna find a is equal to m times g plus, after replacing acceleration with p divided by m plus capital M, we are going to have p divided by root square root of 3 times the total mass. And for b, we are going to have m times g minus p divided by root square root of 3 times m plus capital M. So these are going to be our solutions.